Welcome to week 2. The good news is I got a new microphone, so the sound quality will be better than the previous week from here onwards. Okay, now today we will discuss about a special trigonometric substitution called inverse substitution. Right? Now in this table it is a kind of a summary of the substitutions that we are going to use. So let's start with an example, right? Then you will see, because the reason for choosing an example is there are three categories of this inverse substitutions, and also I will tell the reason for calling them as inverse later on, but first we'll start with an example. Okay, right. Now for the example we consider the integral of this one. Okay, so the special property that we need to highlight here is that we have a square root, right, along with an x term as well as a certain digit, right? Say for example, now this one we have 9 along with x squared, right? So these types of square roots will fall under one out of these categories. So in the case of this example, which is 9 minus x squared square root, now for these substitutions the only thing that we need to focus is with the square root. Okay, so and the remaining parts will eventually fall into correct pieces, right? So our only concern should be on this square root sign, right? So inside the square root we have 9 minus x squared term, and that 9 minus x squared can be visualized as one of these three categories, right? So here we have, now as we in all these three categories, as we have a digit squared with x squared. Okay, so we should have, first of all we should have some number squared, right? So in the given example we have just 9, right, as the number. So first of all we should write it as a square of another number, which is 3 squared, right? So then it will match exactly with the first category of our table, right? Now we have figured out that the problem that they have given falls under the first category. Now let's see how we are going to use the substitution, right? So if the given problem falls under the first category, we will be using this substitution. But there's another thing. When we are using this substitution, now see here we have a theta, and here this is the original term, right? Now this theta we consider it to fall under this range, right? You will see why this is important when we are solving the problem, right? So for the time being, just bear with me. Okay, right. Now as we have a standard substitution for this category, we go ahead and use it as our substitution. So here we have a is equal to 3, therefore according to the table we have x equals a sine theta. That means x equals 3 sine theta, where theta belongs to the given range, minus pi by 2 to pi by 2. Okay, you will see why this is important later, right? In a moment. Okay, right. Now, as we have the substitution, we are going to use it in place of x and see what will happen. Okay, so if I name this as I, then I becomes the integral of 3 squared minus x squared, which is 3 squared minus, now x is this one. Okay, so it becomes 3 squared sine squared theta, everything in a square root, and in the denominator it's x squared. So since x is 3 sine theta, it becomes 3 squared sine squared theta, right? And how about this term? Now, since we have replaced everything in terms of theta, we cannot have a dx term here. Okay, we should also have a corresponding relationship in terms of theta. So to find that one, we can just differentiate our first this equation. Okay, so when we differentiate with respect to theta, it becomes cos 3 cos theta. That means dx can be written as 3 cos theta d theta, right? So in place of dx, we can just write 3 cos theta d theta, right? Then once we have once we write everything in terms of theta, then the simplification will be very easy, right? So in here you will get 3 squared times 1 minus sine squared theta. Now this is the nature of these type of calculations, right? 3 squared sine squared theta and 3 cos theta d theta, right? Now here we can apply our favorite trigonometric identity, right? Which is sines, okay, red color is not good, sine squared theta plus cos squared theta equals 1. So 1 minus sine squared theta will be equal to cos squared theta, right? Now this becomes square root of 3 squared cos squared theta, and the other terms remains as it is. Okay, now there is another thing that I want to highlight, right? Now this is the place where we are making use of the range of the angle, right? Now the angle is given like this, right? So theta will fall under negative pi by 2 to positive pi by 2. I'll tell you. Now I am going to explain why this is important. Okay, right. So inside the square root, what we have is 3 squared times cos squared theta, right? So square roots can be distributed across a multiplication. You can write it like this. Okay, how about the answer for this one? Now at the very first side, you might tend to write it as 3 cos theta, right? But there can be you might be missing an important definition, or important definition of square root, right? So now this is sometimes you might have missed this fact when you are learning square roots, right? So that fact is, if you have something like this, okay, the square root is defined as the modulus of x, right? So for example, if we have negative 5 squared square root, okay, the most appropriate answer for this one will be the modulus of -5, which is equal to 5, okay. And if you have a positive number squared square root, then it is again equal to 5, positive 5, the modulus, and that is also equal to the same number, right? So you might be wondering, what do they mean when we write it as this one, right? Sometimes you might write the answer for a square root like this, right? No, not 5. How about this one? 25. Is this correct or not? Now, these are some trivial mathematical steps that most of the people go wrong, okay. So this equation is actually not correct, okay. Now we can visualize 25 as 5 squared. If we write it as 5 squared, then we have this one, and if we even write it like this, then again what you will get is the modulus of 5, which is again equal to 5, right? So as a summary, I should say the square roots are originally defined for the modulus of the square of this number, right? Not the square root, right? So yeah, but how are we going to get this as the result? If we need to get this one as the result, we should first write the square root along with a plus or minus. Otherwise, if you just write the square root like this, the answer is 5, and there is no such answer for this expression as -5. This is wrong, okay. So basically what I want to say is, if you have a squared and if you are taking the square root, the answer will be the modulus of this smaller number, right? Okay, so according to that, our expression will also contain a square root like this. You can even write it as not the square root, a modulus, okay. You can even write it as the modulus of 3 times the modulus of cosine theta, right? Okay, how are we going to get rid of these modulus signs? Now when it comes to the modulus of 3, you can directly write it as 3, okay, because that's how the modulus works, right? The modulus of 3 is just 3, as it was in this step we also use that kind of a fact, okay. How about the modulus of cosine theta? This is the place where the angle comes into play, right? So the key point here is to understand that if we have a positive term inside the modulus, for example this one, we can just write the positive term as the answer. And if we have a negative term inside the modulus, we should write it without that negative term. Now, if I express this one as x, right? Now here x is equal to 10, right? So the answer should be equal to 10. That means it is again equal to x, right? But if this answer, like if this number negative 10 is expressed as x, right? The answer of this modulus will be equal to positive 10. In other words, that will be equal to negative x because x is negative 10. So altogether it will give you positive 10. Reason is from the modulus you should get a positive term. And if the inside number is also positive, then we don't have to worry that much. You can just write the same number without the modulus, right? And in our problem, as we have the angle theta within this range, cosine theta will be positive in this range. Remember, cosine theta is, now if we, this is the quadrants, right? All the trigonometric terms are positive in the first quadrant. Here sine is positive. In the third quadrant tan is positive. In the fourth quadrant cosine theta is positive, right? So that means when angle is in between 0 and 90 as well as negative 90 to 0. So if the angle is in between this region, cosine theta will be a positive number, right? So we can just disregard this modulus term and directly write the answer as cosine theta. Okay, right. So that's the importance of having having a range for the angle. Okay, right. Once we are done with that one, then it's just a matter of simplifying the trigonometric terms. Okay, so this is equal to 3 cos theta. That means our integral will be equal to 3 cos theta, and this one will be the same, 3 cos theta, and in the denominator you have a 9 sine squared theta. Then by simplifying it a little further, you can have 9 cos squared theta sine squared theta, and then these two 9s will get cancelled out. So what you will have is cot squared theta, right? That is sine theta over cos theta is equal to tan theta, and the reciprocal of this one will be equal to 1 over tan theta, which is equal to cot theta. So in the given expression you have the square root of all these terms, so everything will be squared. So you will have cot squared theta, and this is another trigonometric identity that we should have in mind. Cot squared theta is equal to cos x squared theta minus 1. That's a trigonometric identity. Then we can separate the integral across these two terms, and then the integral of cos x squared theta is equal to negative cot theta. That is a standard result, and the integral of this one is just theta. Also, don't forget to write the arbitrary constant. And now here, see, here we have our main goal was to find the integral of the given original problem, right? Which is this one. Okay, so that means the answer for 9 minus x squared to x squared is equal to minus cot theta minus theta, right? But still there is something not nice, right? In the given problem it is given in terms of x, right? But in the middle of the calculation, we have introduced a term with theta, and we have kept the final answer in terms of theta, right? That is not good. We should convert everything back into x variables, right? Now I am going to teach you how to convert all the variables back in terms of x. It's not a difficult thing at all, but it's just a standard procedure that we have to follow, right? So the method is, we can use the substitution, which is x is equal to 3 sine theta, right? So that's the substitution that we have used, and we need to find what cot theta is. Now our initial substitution is x is equal to 3 sine theta, right? And from this one we need to find cot theta and theta in terms of x, right? A very easy way to do this one is, we can rewrite our initial equation as sine theta equals x over 3. I just take this 3 to the other side, okay? And then if we draw a right angled triangle, and if I mark this one as theta, right? Sine theta represents the relationship between the opposite side and the hypotenuse, okay? So sine theta is basically the opposite divided by the hypotenuse. So according to this relationship, opposite side should be equal to x and the hypotenuse should be equal to 3. Then only you will get this relationship, okay? Right. So now we have a right angle triangle and we know two sides of it, right? So now it's just a matter of finding cot theta by using this right angled triangle. Now cot theta is the inverse of tan theta, not the inverse, sorry, the reciprocal of tan theta, and tan theta will be equal to the opposite side over adjacent side, right? So yeah, that means the reciprocal of tan theta, that is cot theta, will be equal to the adjacent side divided by the opposite side. And so for that we need to find the adjacent side, which can be easily calculated by the Pythagorean identity, right? So this is the adjacent side and the opposite side will be equal to x. That means cot theta will be equal to this term, right? And how about theta? Now theta, as we have this relationship, we can easily write theta as the sine inverse of x over 3, okay? This is the same as arc sine, okay? Right, now we have all the results to write the answer for the given integral, which is 9 minus x squared square root divided by x dx, and that is equal to negative cot theta, which is this one, 3 squared minus x squared over x, and minus theta, and that is equal to sine inverse x over 3 plus the arbitrary constant. Right, so let's summarize what we have done. Initially we had a problem. The initial given integral had a square root inside, right? And inside the square root we have some digit. It is of the format of one out of these three categories, a number squared along with the x squared term, right? And it falls under the first category, so we used this substitution. And also when we are using that substitution, we should remember that the angle should be within this given range, okay? And so once we are using this substitution, this trigonometric identity is useful, because when we are using that substitution, eventually we will get into a situation where we will have to use that given trig identity. And once that trigonometric identity is being used, we will have a squared of that cosine of a cosine term or a sine term, right? So since this square is inside the square root, we should be able to write it. And also, as we have this nature of a square for the square root, we should be able to write everything without a modulus sign, because when we have a modulus sign, things will be much complicated and it will be very difficult to handle, right? So to get rid of this square root term, to get rid of this modulus term, we make use of this given angle. And once we get rid of that modulus term, then the remaining trigonometric terms will be easily simplified, right? And then you have to remember a couple of standard integral results, and then you can have the final answer in terms of theta. Then we should convert everything back into x terms. So to do that, we make use of the initial substitution once again. From the initial substitution, we take a relationship for sine theta or the corresponding trigonometric variable, and then we draw a right angle triangle, mark the edges, these sides properly, and since this is a right angle triangle, we should be able to find the unknown side. So once we know all these three sides, we can write whatever the trigonometric term just by looking at this triangle. So finally we can leave our result in terms of x, and also don't forget to write this arbitrary constant.